All right, today we're starting section 7.2. We'll get the objective up there in just a minute. We'll start off with our ratios. Hopefully these went pretty quickly. The first one, what is our first step? Just to simplify it, the units are already the same, inches and inches, so we can simplify it. If it helps, you can rewrite it as a fraction. If it makes it a little more clear how it'll simplify. What are both of those numbers divisible by? 2. So this becomes what? Good. 3 inches over 14 inches. Again, if you want to leave this in a fraction form, that's fine. If you want to switch it back to having a colon in the middle, that's fine. On number 2, what do we need to be looking out for? Good, the units are not the same. So we need to make sure our units match. We always stick with the smaller unit, which means in this case, which unit are we wanting to keep? We want to keep feet, which means we need to get rid of yards. So we know in 1 yard there are 3 feet. Okay, so the yards cancel out, but we keep the feet. Multiply straight across the top. What do we get? Good, 2 feet over 6 feet. Now that the units are the same, what do we still need to do? Simplify the fraction. What do we end up with? Did we say 1, I hope?
Yeah, 1.
Okay, good. 1 foot over 3 feet is correct. Questions, concerns? All right, last one. Again, we need to change what? The units. 12 days, okay. Which unit are we keeping? Days. The smaller unit is the one that we keep. So we want days on top, weeks on bottom. So the weeks will cancel. So how many days to how many weeks?
7 days in 1 week.
Good. There are 7 days in 1 week. So that's our conversion factor or scale factor. Then we multiply across the top and across the bottom. 6 times 7, 42 days to 12 times 1, 12 days. Are we done or do we have more work? More work, because this will simplify. We can divide them both by 6. Good. 42 divided by 6 is 7. 12 divided by 6 is 2. So 7 days to 2 days. Again, I default to writing my ratios as fractions. I think that's easiest and probably the most common. If you want to write it with a colon or the word 2, you can do that. Questions about ratios? If you weren't here yesterday, these warm-ups are a pretty good synopsis of what was going on. Next up, solve the proportion. So in these, one thing I'll review before we actually solve it is some of the terminology. Does anybody remember what term describes, in this case, the x and the 14, Lexi? So means and extremes. Chloe, which one did I circle? Good. The extremes are what I circled. The first thing and the last thing. The other 2, the 7 and the 2, are called the means. So it's just a little vocab review from yesterday. In order to solve proportions, we take the cross products. So we multiply the means together, we multiply the extremes together, and we set them equal to each other. So when I multiply my extremes, what do I get? 14x. When I multiply my means, I get 14. Now, yesterday we wrote out 14.x equals 2.7. If you go straight to this, that's fine. I think most of you know 2 times 7 pretty quickly. But we're not done. We have to solve it, which means we need to divide. And x equals 1. Good. Number 5 is a little bit more challenging. What symbols would I recommend you putting in right away? Parentheses. Now, whether you do it right here or you wait until you take your cross product, that's fine. But we need parentheses in there so that we remember to do what? Distribute. So when we take one of our cross products, we're taking 3 times x minus 1. Thank you. So we're taking 3 parentheses x minus 1. You got to multiply it to the whole denominator. What's my other cross product? 9 times 2, which is 18. We've got a couple steps to solve this one. We already said we need to distribute, so let's do that. What do I get when I distribute? 3x minus 3 equals 18. Add the 3. 3x equals 21. Last step. Divide by 3. X equals 7. Beautiful. All right, today we're going to bring a little more geometry back into this. We are going to identify similar polygons. You'll see hopefully pretty soon why we did that section on ratios and proportions, because we will need those skills when working with similar polygons. Anybody need more time with their objective? Alrighty then. Here we go. In geometry, 2 figures that have the same shape are called similar. 2 polygons are similar polygons if corresponding angles are congruent and corresponding side lengths are proportional. If we used the word congruent, bless you, in both places, then we would be talking about what we did last semester. We already talked about congruent figures. We're shifting our focus to ones that are just similar. The symbol for similar is a little squiggly, tilde, whatever you want to call it. Remember that congruent was that squiggly with an equal sign under it. So now they're not congruent, they're just similar. We take away the equal sign. So for example, if I was talking about last semester with congruent figures, I would have 2 squares that are exactly the same. All the sides would be the same, all the angles would be the same. That would be congruent, so I'll box that off. Congruent's what we've done before. Similar means that all the angles are the same, so that's why I chose squares, because they're pretty easy for all the angles to be 90 degrees. But the side lengths are just proportional, which means they're not exactly the same. I could have a smaller square and a bigger square. These are similar to each other, but they are not exactly the same. Do we see the difference between similarity and congruent? Similar means they have the same shape. So congruent, angles, proportional sides. Questions, concerns, or need more time on this slide? Need another moment? Ooh, that is fuzzy. Luckily, you have it printed on your page, so we'll just talk about it, reading it off of the notes. Let me get a copy for myself, and we will fix this up a little bit. All right, first up, we have to list all pairs of congruent angles. That should be easy to do just based off of the similarity statement they gave you up at the top there. So they wrote at the top of that problem, JKLM is similar to WXYZ. This is going to feel familiar from when we did congruent figures last semester. So angle J is going to be congruent to which angle? W. Why? They come first. So remember last year with our congruent statements, the first letter and the first letter, those angles had to be congruent. Which means that angle K is congruent to angle X, angle L is congruent to angle Y, and angle M is congruent to angle Z. Okay, so up above we wrote that in similar figures, corresponding angles are congruent. That part will feel familiar. Questions about 1A? Okay, 1B asks us to write the ratios of corresponding sides in a statement of proportionality. Now, this again is going to feel a little familiar, but because it's not congruent, it's proportional, we are going to set up an extended proportionality statement. So we're going to have 4 ratios because each of these figures has 4 sides. When we fill in this statement, it'll kind of go like it did with congruent figures, where we can still use the statement they gave us to match them up in their ratios. So the first ratio, I'm going to compare side JK to what side from the other one, if you had to guess? WX. So those two are proportional or in a ratio with each other. Side KL gets compared to side XY. We see this pattern here. First 2 letters matched up with the first 2 letters. Middle 2 letters, middle 2 letters. So the next one would be side LM compared to YZ. And the last one, JM compared to WZ. So we haven't even used the figures they gave us yet. All we had to use was the statement of proportionality or similarity from above. Questions, concerns? Okay. Part C is when we finally start using the diagram. So we are going to plug in numbers to all of these ratios and make sure that they actually do come out to be proportional or equal to each other. So one at a time, we're going to find the ratio, and if we can, simplify it and make sure they all simplify to the same thing. So, I know it's hard to see on the screen, but on your note page, what is the length of side JK? 4. And that gets compared to side WX, which is 3. Can that one be simplified? No, so we're going to leave it alone, move on to the next one. So we're going to hope that they all simplify to 4 over 3. Next one, KL over XY. Those can both be divided by 4. 16 divided by 4 is 12 divided by 4 is 3. And that's what we would have wanted to see. We want them to reduce to the same thing. Next up, LM. 8 compared to YZ. Those are both divisible by 2. 8 divided by 2 is 6 divided by 2 is. Once again, that's what we wanted to see, so we've got one more to check. JM is 12 compared to WZ. Those are both divisible by 3. 12 divided by 3 is 9 divided by 3 is. So check. Like we checked it. They all matched. They are proportional to each other. So I understand the work on this gets a little tedious. Thank you, Bella. The work on this is a little tedious, but it's not hard. Okay, you plug in numbers, you reduce the fractions. Questions, concerns on example 1? Okay. On to the back. I'm guessing, yep, fuzzy again. At least it's nice and clear on your page. So our directions on your page say determine whether the quadrilaterals are similar. If they are similar, write a similarity statement and find the scale factor of FGHE to ABCD. Lot to do here. So the first thing is to decide if they are similar. We have 2 criteria for similarity that we wrote on the front of our notes. What is one of the criteria for being similar? So they have the same shape, but how are we going to know that? Okay, so corresponding angles are congruent and corresponding sides are. Okay, so these are the things we need to check. Proportional. These are the things we need to check in order to determine if it's going to be similar. We're going to repeat these 2 criteria a lot throughout this chapter. So the first one's easy to check in this case. Do we have pairs of corresponding angles that are congruent? If you look in that figure. Yes, like angle B, they marked with 1 arc, and that would correspond and be congruent to which angle from the other figure? G, which they also put 1 arc in. And we can match those up all the way around. 2 arcs, 3 arcs, 4 arcs. Are we all okay with seeing that the angles are congruent? Okay, so we'll check that off. We saw that. You could make a note marked in diagram. Marked in diagram. There's really nothing for you to calculate or show for that. It's already shown to you. The thing that we do have to take time to work out would be to show that the sides are proportional. So in order to do this, you need to be matching up your smallest side of one figure to your smallest side of the other figure and work your way up. Or start with the biggest side from one to the biggest side of the other. Meaning in this figure, I'm not going to match up the side of 28 to the side of 5. Okay, I'm not going to try to mix and match. If I'm trying to match something to the side length of 5 or FG, which one is that going to have to get paired up with from the other figure? BA, which has a length of 7. Does that make sense? You've got to pick them small to small, big to big. So, I am going to start with the figure on the left and put this one on top. And then move to this one and use it as my second one, or the one on the bottom. Just because later on in the directions it says the scale factor of FGHE to ABCD. Do we all see that in the directions a little later? So they're saying start with this one, move to that one. So the first one we already talked about. We're going to match up 5 to 7. Can that be reduced? No. So that's what we're hoping they all reduce to. What is the next biggest side of our first figure?
14.
Careful. Remember I said this one, FGHE, is going to be my first one.
15.
Careful. 10. Okay. So we're going to match 10 up to 14. And then that can reduce. They're both divisible by 2. Reduces to 5/7. That's what we wanted. We've got 4 sides, so we better be doing this 4 times. What's my next biggest side? 15 gets compared to, they're both divisible by 3. 5/7 again. We're on a roll. Last one should be the biggest side compared to, divisible by 4. Again, 5/7. So we checked that the sides are proportional. So my work is below on that one. All right. So there will be some work for you to show. You can't just say sides are proportional, check. You better show me the work for how you know the sides are proportional. Okay. They are similar. So we are going to write a similarity statement. It is easiest to do this, in my opinion, based on angles. So again, we're going to treat this as our first figure. What angle do you want to start with? Okay. So starting with H, just work your way around and name that figure. So remember, the first figure you can kind of name however you want, and the second figure is going to be the one you got to be careful with. So we could build it a little piece by piece if you want to do it that way. What letter do you want to come next? Here. Which one? E? Okay. So what letter has to come next on the other one? D. Okay. Back to the first one. What letter has to come next? F. You've got to work your way around in order. So if you went H to E, you have to go to F next. So from C to D, we would go to A next. And the last letter for the first one is G. Last letter on the first one, or second one, is B. Now this is not the only option. You could have named the first one E, F, G, H. And in that case, it would have been similar to D, A, B, C. Right? You can kind of pick how you name the first one, but then you have to match it up to the second one. There are other options. Questions, concerns about the similarity statement? So this is another option. You don't need both. Notice I put a squiggly in between them, not a congruent sign. If you put a congruent sign here, it's getting marked wrong. So these are the similarity statements. But we're not done. What's the last part of these directions? Find the scale factor. Lucky for us, we kind of already did that. Your scale factor is going to be that ratio that you get when you simplify the sides. What ratio did we end up with every time? 5/7. And because we set it up from this one to that one in the beginning, we can go ahead and use that. So our scale factor, in the future I might abbreviate that SF. Our scale factor is that ratio 5/7. Okay, so it's one problem, but there's a lot of work to do on. Do we have questions, concerns about any of the directions, any of the vocab they used? Okay, one thing I'm going to just write off to the side here down at the bottom. When you're reading the directions, if they ask for a similarity statement, then they mean one figure, so A, B, C, or it could be bigger, similar to X, Y, Z. That's what it looks like to have a similarity statement. If they ask for a statement of proportionality, that's different. We didn't see that on this one, but we did on number 1. For proportionality, it would look like something AB over XY equal to BC over YZ equal to AC over XZ. So in the directions, you need to know what they're asking for. If they're asking for a statement of similarity, it should look something like the top. If they ask for a statement of proportionality, I should see a bunch of proportions or ratios set equal to each other. One of the tricky parts about this lesson is knowing what the directions are asking you to show. Questions, concerns? Need more time? Okay. In a minute, we'll move on to the bottom. I guess we just eliminated example 3. Just move on to 4 and 5. We ready? Okay. On we go. Oh dear. Fuzzy on my screen again. Okay, so on these, we are told that triangle ABC is similar to triangle XYZ. We are asked to find the value of X. In this case, you cannot rely on matching up smallest to smallest, biggest to biggest. That only works when all of the sides are labeled. But here, we don't know this side BC. We don't know if that's the biggest side or if that's the smallest side. So we have to use a proportionality statement to help us out. You don't necessarily need to write out the whole proportionality statement. You really only need one proportion. So I'm going to take this one away for a minute while we focus on this first example. So I'll just write these in to help us out a little bit. A, B, C, X, Y, Z. Okay. If we look at the similarity statement they gave us, then AB is put in a ratio with what other side? XY. Good. Equal to what side would come next on top? BC compared to side YZ. We could go ahead and make the last ratio, but we don't need it. Which side here don't we know? BC. We don't know BC, but we know all the other ones. So now we can go ahead and fill numbers in. What is the length of AB? The length of XY. The length of BC. The length of YZ. Okay, so we don't need the last ratio. If you wanted to use it, you could have. Instead of using AB over XY, you could have used AC over XZ. But you don't need it. Are we all understanding why this is all we need? Okay, we've got our unknown side. We have a proportion set up. How are we going to solve it? Cross multiply. 15 times 6 is 90. And of course, 9 times x is 9x. To solve it, we have to divide x equals 10. That's all they wanted. Find the value of x. That's what we did. Questions, concerns about that one? Nothing? Warm, fuzzy feelings? Okay, can I take this one away so we can do the last one? I'm going to take your silence as a yes. All right, bring on the last one. All right, so just look at the diagram on your page since mine's so fuzzy. We can still use that same proportionality, AB over XY equal to BC over YZ, because we have the same similarity statement, we just have different triangles. So we can fill in what we know. AB has a length of XY equal to BC, X, and YZ. 10. Questions, concerns? Okay. We got to cross multiply. 3 times 10 equals 6x. To solve it, we divide x equals 5. Questions, concerns about 7.2? Okay, so friendly reminder, those of you that were here yesterday should remember. What did I say was coming up on Friday? A quiz. So tomorrow we are going to practice what we've done so far. On Friday, we'll take a quiz over it. Hopefully these lessons have been easy. We can start the semester out with a good quiz grade.